Inheritance is an object-oriented programming concept or mechanism that allows us to define a new class which inherits all fields and methods of a parent or superclass. Say this is the previously defined class. We call this the parent or the superclass. And the new class, we call this the child or the subclass. How do we define the new class so that we employ inheritance? We do so by saying, say the access modifier we use for defining the new class is public. We say public, and then the name of the new class, say for example, new class is the name, and we say extends. We use the keyword extends to employ inheritance, and then followed by the parent class or the superclass, which is the old class. Say this is the old class. So this new class is called the child class or the subclass, while this old class is called the parent class or the superclass. We use the keyword extends to employ inheritance. And then open curly to mark the beginning of this new class and close curly. So this open and close curly defines the scope or the block of the new class. Say for example, we don't define in here any field or method for the new class, then the new class will simply have all the fields and methods of the parent class. So the new class has method 1 and field 1, which are inherited from the old class or the parent or the superclass. So when we employ inheritance by defining the new class, which is the child or subclass this way, where old class is the parent or the superclass, when we employ inheritance, then all the fields and all the methods of the parent or superclass are inherited by the new class, which is the child or the subclass of this parent or superclass. So again, take note, all the fields and methods of this parent class are inherited, or automatically the new class or the child class will also possess all of those fields and methods. And then the new class may have its own proprietary fields or methods. Proprietary means its own unique fields and methods. So for example, in this case, for the new class, the child or the subclass of the parent class, we have field 2 and method 2 as the proprietary fields or methods. These are unique methods and fields that are proprietary or unique to the subclass. Okay? Only field 1 and field 2 are inherited from the parent or superclass, while field 2 and method 2 are unique or proprietary to the newly defined child or subclass. When we define the child or subclass such that it has its own unique or proprietary fields and methods, then we are employing extension. So extension is when a new class can add other fields or methods. We call that extension. So when we have field 2 and method 2 defined in here, so those fields and methods which we define in here in this block, those are the proprietary or unique fields and methods to that new class or to that child class or subclass. So the new class will now have all the fields and methods from the parent class and all the fields and methods which we define in here when we employ extension. So again, when we employ inheritance, the new class, which we call the sub or the child class, can inherit all the fields and methods of another class, which we call as the parent or the super class. In this case, this is the parent or the super class, and this is the child or the sub class. And take note that all fields and methods of the parent class are inherited by the new class. And you can add other fields and methods to this new child or subclass. Say we add field 2 and method 2, then we are employing what we call as extension. So this is inheritance with extension. These two, field 2 and method 2, are the proprietary or unique fields and methods to this child or subclass. These two are not coming from the parent class. Only these two are coming from the parent class. These are inherited. This is by employing extension. And a new class or the child class can also redefine the inherited methods of another class. And when the child or subclass redefines or revise the implementation of the inherited method, then we are employing what we call overriding. It's the customization of methods or functions. So once again, overriding is when the subclass or the child class revise or redefine or change the implementation of the inherited method. Say for example, this method from the parent class is void it. Say this parent class is animal, and animal parent class has the method it, and the implementation is simply to output system out that println it anything. And then the subclass or the child class is called dog. Okay, this is the sub or the child class. So we define dog this way: public class dog extends animal. And then in here, we define void it, and the implementation of method it is system out that println it's dog food. So the implementation of this method void it without arguments is it's dog food. Okay, that's the implementation. The statement inside the curly braces of this method void it. This is the revised or the redefined method which is inherited from the parent class animal. So what happened here in the subclass or child class dog is the inherited method, which is this one, it without parameters coming from the parent or superclass animal. The implementation of that is changed because in the parent class animal, the implementation is this one, which is system out that println it anything, while for the dog subclass we change the it method to it's dog food. Okay, so this is a redefinition of the inherited method. So again, when a new class or a child or subclass redefines an inherited method, we call that overriding. Say we have in here a package with the name Animal Kingdom, and in this package we have 3 Java classes. First one is animal.java, which is this one. We call this the parent or super class. And this parent or superclass animal has one field, which is this one, scientific name of string type, and it has three methods: eat, sleep, and play. And for method eat, this is the implementation. For method sleep, this is the implementation of the method. For method play, this is the implementation. And say we also have this Java class dog, which is what we call the child or subclass. So in here, we employ inheritance, where dog is the child or subclass and animal is the superclass. So dog is the child class and animal is the parent or superclass. And say we have another Java class with the main method, and so this is the one which we can run or execute. And in the main method, we instantiate animal and dog just to check what the instances for animal and dog have as fields and methods. So if we're going to reference that instance and try to access all the fields and methods that instance A, which is class type animal, has, so the instance A, which is class type animal, has field scientific name, method eat, method play, method sleep. Okay, all the rest of these are attached to it automatically as a class type. So these are all the rest of the methods that we can execute for A being a class type. Indeed, since A is class type animal, it has scientific name, eat, sleep, and play. Now, how about dog or D? Say, this is D. D dot D, an instance of dog, has also scientific name, eat, play, and sleep. Okay? So, exactly what animal class have as fields and methods, dog class have them also. Okay? The instance A, which is animal class type, and instance D, which is dog class type, these two have exactly the same fields and methods because D is dog type and dog is a subclass or child class of this superclass or parent class animal. So all the features or fields and methods of animal are inherited by this subclass dog. Now, if we're going to write in here unique fields and methods for dog, in that way we employ extensions. Say, for example, we have here a proprietary method guard, which is unique to dog class, and the implementation is guards human owners properties. Okay, so this is a proprietary method or unique method for dog class type. By defining this new method here, we called guard, we are employing extension. Again, what is extension? Extension is an OOP concept where a subclass or a child class add some methods or fields which are proprietary to itself or unique to itself, and these methods are not inherited or coming from the parent class. Okay, these are unique to dog class. We are employing now here extension. By this keyword extends, we are employing inheritance, and by adding this new method which is unique to the dog class, we are employing extension. So let's save this and try to check what are the methods and fields of D. Now we have guard. Okay, so D, being a dog class type, has scientific name which is inherited from animal. Eat, play, and sleep are all inherited from animal, while the guard method is its own unique method. This is not inherited from the parent class. So all in all, the dog class has everything that animal have, this field, these three methods, plus this new method which is proprietary to itself. So that when we say d dot it, then you say d dot play, you say d dot sleep, and d dot guard. Okay, so when we execute all the methods, these are all inherited from the parent or superclass animal, and this one is unique. This is by extension, and all of these three are by inheritance. This one, and this one. So let's run this. We have this output. It's anything, anytime, anywhere. That's the implementation from the definition here in the parent class animal. And then for the play, it's the same implementation from the parent, plays anytime, anywhere. And sleeps anytime, anywhere is also the implementation from the parent class. So all of these are the result of the execution of the implementation of the parent class methods, while this one is the execution of the implementation of this new method, which is created by extension. So in these three method calls, we are executing the method of the parent or superclass animal, while this one is we are executing the method of the sub or child class itself, which is the direct class type of the instance D. Say for example, we will employ overriding. What is overriding again? It is when the child class or the subclass, example dog, will change or redefine or revise the implementation of the inherited method. Say for example, in here, we are going to redefine the implementation of method it. Take note that this method is inherited from the parent or superclass. Why do we know that this is exactly the same method as the inherited method from the superclass? It's because the return type is the same. This is void. This is return type void. The method name is it, the same as here, it. And the argument pattern is 0 arguments. Here it is also 0 arguments. So when these three are the same, the return type, the method name, and the argument pattern of these two methods, then they are exactly the same. They are referring to the same method. This is not an additional method to dog. This is the inherited method coming from the parent class, but we are just overriding it, or we change or redefine the implementation of the inherited method. Okay, that is what we call as overriding. So instead of the implementation from the inherited is saying it's anything, anytime, anywhere, say we change this to it's dog food twice a day inside the house. So the eat method of dog says it's dog food twice a day inside the house instead of it's anything, anytime, anywhere. Okay, save it, and then let's run this again. So this d.it now would execute what? The it here in the parent class or the it method of the child class. Which do you think will be executed? This one or this one? Okay, let's try to run this. Okay, remember this is the output before. When we run this again, the it method is now the one with the redefined implementation. Okay, so we are now executing the it method of the dog class, the one which we redefine. So this is the method that dog class overrides. Okay, so this is the execution, and then play and sleep are those from the animal class. These two are from the animal class because we did not override the sleep and the play method. We keep it the same as the original. And then the guards is this one.